All right.
Thanks. Take it away. Take it away.
All right. So I have a lot of stuff to tell you, and some of it is recent history. A lot of it's present, and then there's a little bit at the end, if we get to, I hope, about the crazy future, which none of us can predict. So here we go. But the first thing I have to tell you is from our lawyers, and it says that you can't believe anything I say. And also, here's my warning. These slides are posted, so you're going to, I'm going to go through this really fast under the assumption that if you saw something you liked, you can go back and find it. So it's all there. And boy, that link font is really hard to see. Is that really terrible? All right, but I promise it's there. I'll blog it too. So I can't remember the last time I used a coffee joke, but this is the day for it. And so here's what's brewing. The two release drivers for JDK 8 are Jigsaw and Lambda. So I'm going to tell you about Jigsaw, but there's also some other stuff that's mixed in. There's the really cool Nashorn JavaScript engine, which uses JDK 7 features. And we're also, of course, mixing together our JRocket and JVM, Hotspot JVM technologies. So that's really exciting, both from a sort of a personnel point of view and a technology point of view. I'll have a slide on that later. I'll have a zillion slides on Lambda because I think that's cool, and I think the people in this room will appreciate it. And then there's a little bit about collections, which that's an elaborate pun, by the way. We are going to go into collections to eradicate some of our technical debt and hopefully not go bankrupt. And there's a whole lot more in JDK 7. For those of us who like Macintosh, it's happy news that that Mac is now a supported platform, so that I can actually continue to use Mac as my development platform for Java. Yay! This is the wrong place to be saying that, but that's okay. So a little bit about Jigsaw. You can find out the real stuff about Jigsaw from Mark Reinhold, who knows all about it. But I'm going to give you sort of my one-slide take on what's important about that. And the most important thing is no more class path hell, explicit dependencies, not implicitly determined by the order in which Maven puts it for you. So that will hopefully make us a lot more sane. The trick there, of course, is to have a consistent dependency model across all phases of development and deployment. So this is non-trivial. Good thing is that it's been solved multiple times in the past, so I'm sure we can figure it out. Another aspect that we're going after with Java modules is real encapsulation. So just as a private field is private, a private class within an assembly, that's the wrong term for Java, but a private class ought to not be visible outside of its module, except unless, of course, it's exported. There's all the funny degrees of freedom you get when you think of modules, plug and play and provide and fail back if something's missing and so forth. And then finally, we have an explicit goal not to use class loaders as fake modules. So it will actually be a civilized case where you might just have one class loader with a module structure inside of it instead of using class loaders to fake up modules. So that's good, and of course it will work with everything in the universe, and that also is non-trivial. But that's what we're working on, and that's going to make a lot of people's jobs easier once we get that solved in 8. What else is going on? Well, there's a JavaScript interpreter, which you know about Rhino, and Nashorn is a Rhino by another name. What language is that? Is it German? German. Yeah. It means nose horn. And so this is a reboot of Rhino using JDK 7 technologies. It's using state-of-the-art data structures, kind of like V8 or Self. It uses Invoke Dynamic from JDK 7 to build its mutable inline caches, and so all the recompilation magic that you get in modern JVMs, where the VM does something optimistic about guessing what your code is going to do, and then it recompiles if it gets it wrong and tries again. That's bubbled up to the user level, or at least the language implementer level with Invoke Dynamic, so they can do the same kinds of games in JavaScript that Java's been doing with interfaces forever. And of course, you get since it's built out of bytecodes, it gets the same benefits as all the other engines that run on top of the VM. What else? I want to say a few more words about convergence. Henrik Stahl has a very good blog where he tracks the convergence and the product life cycle of what is now Oracle's JVM technology. But I'll give you a few points about it. From my point of view, I'm of course on the Hotspot team, and I've got a bunch of new colleagues. So this is sort of a JRocket and Hotspot get together right now. But on the roadmap, of course, is further convergence among other branches of Java, which I am sorry to say I don't know very much about, but I know it's there. The teams have merged, and the JRocket people are delightful to work with. They have moved a lot of their best ideas into in the Hotspot source base, and so now we have monitoring manageability. How many of you have ever been bit by the PermGen problem in Hotspot? Yeah, a few. Even in this room, there would be a few. So the JRocket people have very good insight into how to fix that, and that is a huge project going on right now. And of course, when you get that many smart people from one VM group and you put them together with another VM group, there's a lot of cross-fertilization of ideas. So there's some really interesting compiler optimizations which should be coming out into the open source stream. Stuff having to do with dynamic language support and boxing and unboxing, that sort of thing. Also, the JRocket people broke down and did a manual inline flag back when, and they've convinced the Hotspot people that at least for language engineers, there should be such a nasty switch. So you might see that in the code coming up. You know, it's called force inline. Don't tell anybody I told you. So Lambda, how far in am I? Oh, this is great. I think everybody understands, especially people in the .NET world, what the big goal is that's motivating Lambda. It's that you want these streaming queries that are over data structures which are not made explicit until perhaps the end. So you need to be able to say, I've got this big bulk of data. I want to be able to map it and filter it and eventually reduce it down to something, get the one drop of liquor that I'm trying to distill out of it. So this is something that is well described, for example, in Brian Getz's recent DevOps talk, which there's a link in there for you if you want to go back and look at it. But here's sort of the big one-slide goal. We want parallelism. The hardware designers are making life difficult for us software people by not building just simple single-threaded von Neumann machines anymore. It's really frustrating. I wish they'd go back. But in any case, it looks like we have to sort of reinvent some of our languages and make this parallel hardware, at least until they get tired of making the parallel hardware, making it run our data sets well. And that involves parallel collections quite seriously. A goal that has worked well with LINQ is to make parallelizable or remotable queries look like local ones, right? So you leverage the same syntax across multiple engineering domains. Let's say it's sort of, in some abstract sense, it's the same problem, but you want to give the programmer a way to move it onto different kinds of computing engines without completely changing his code. So we all understand that in this room, and Java understands it too. So the hard part there, of course, is changing the language, because we've got an enormous, rightly wary of change group of customers. So here we go. Let's see. What do we need in this big goal that requires lambdas? Well, we need internal iterators. We need to pass the loop body into the collection rather than pull the elements one at a time out of the collection. We need the chained queries so that we don't prematurely or accidentally reify the intermediate results outside of their encapsulation. So we don't want raw arrays or raw accumulators. So at the bottom is one of Brian's examples for the sort of query we want to be able to write. And then, of course, the next step beyond that is add a little engineering hook where you can say people.asParallel.filter blah, 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 or people, as distributed or something like that, filtered blah, blah, blah. So the chain stays the same, but there's a little tweak on the root of the chain. And this is, again, this is not very new, but it's quite cool. So let's get into the details of what's in the Lambda guys. That's kind of fun. And there's another blog post from Brian Getz that I've linked for you there. It's not going to be surprising to anyone here that it's parameters in a body with an infix operator. We had to change the arity of the arrow just so we could pretend we're creative. Sorry, there's plenty of things to be creative about other than syntax. Then of course, as I've notated here, there's a type that's sort of floating around with the lambda that affects how the lambda is interpreted. And that, of course, you are to think of target typing here. So there are some examples, which are easy to read. The target type comes not just from a cast, but from an assignment or any of those other kinds of things that target types come from. You might think that target typing is new in Java, but it really isn't. Gilad put it in, although maybe he didn't intend to, in Java generics. So we've just said, okay, the door is open. Now we're going to use context to not only just infer by unification what types are of the expression, but we're going to sort of pound target types down in. And the diamond operator is a Java 7 example of that. And then this is a more radical example where you can't even tell what the body is in any terms until you've looked at the target type. Parameters, can omit parentheses, can elide types. Body can be expression or block. We do have return that means return to the body of the lambda, which I don't personally like, but it's what people are used to. And then I already mentioned the arrow shaft as a difference from C#. There's some other more interesting differences from C#. Probably the most fundamental one is that the types that we use to describe lambda signatures are just old garden variety functional interfaces from Java 1, runnable and so forth. So there's a parallel choice that the user has to use inner classes or outer classes or however else you want to make interfaces, proxy generations, whatever, or you can use lambdas. So it's all sort of on the same level. Whereas, delegates are a more special thing in C#. They're sealed. The details between Java and C# on type inference, of course, have to differ. And I don't understand all the differences, so I'm going to skip over this one quick. An interesting one is, and this is my fault, I suppose, but I'm going to take credit for it. Outer variables captured by lambdas are still going to be final. We're not going to allow Lisp style or Smalltalk style up-level accumulators that you sort of cutely add into as you do your internal iterator. Think about that for a minute and you'll see why it's a bad idea, but I'll explain more later. Another difference with Java and C# is, of course, we still have no reification of types, and that's partly a good thing. And the sad thing is we don't have expression trees, which even today we've seen how cool they can be in Scala. So that's too bad. Maybe someday. Important similarities are that we do have the contextual typing with C#, and as I understand it, C# lambdas have no intrinsic type of their own. Correct. They have to be put somewhere to get a type. Right. That's our play too. And then there's no up-level branching. There was some furious argument about that, and I kind of miss the branching too. But for the sake of parallelism, I think it's better to have the lambda keep its hands to itself. Here's an interesting slide because it's building in the wrong order. But anyway, here is something wrong to do with outer variable capture. That's why I've crossed it out and turned it red. This is your little naked accumulator. It's for parallel programming, it's as bad to jump out of a lambda into a containing scope as it is to peek and poke the containing scope. All right, so I exaggerate. To poke the containing scope. You can peek all you want, as long as you're peeking sort of shareable, hopefully immutable, or at least monotonic structures, but you don't want to poke it. Yes?
Why would you ever have a for each that does not have a return type? What can you do with it except side effects?
Right. It's kind of perverse, especially if it's on a parallel type.
I mean, you said you want to have internal iterators. What good are they?
For mapping. There's something called MapReduce.
Yeah. That's not just an iterator. That doesn't mean you have to have it.
We're discouraging it. We're making it not the first thing you write, when you've been trained on BASIC or C++ or something. So it's the same rule as for nested inner classes, and here's the canonical bad case. I call this the do times bug because I first saw it like 25 years ago writing a do times macro in Lisp. And that's why we have final up levels in inner classes for Java, because I went from my Lisp job to my Java job and said, no way is that ever going to happen again in my world. So that's why finals are final with inner classes. This is why it's bad. I mean, what's going to happen with this code here is you're going to eventually have tasks do number 4, all 4 of them. That's what captured mutable variables mean, and I understand that C#5 fixes that, so that's good. We're going to allow final to be elided under the sort of theory of, you usually don't change things anyway, so don't make them declare it. And if there's the inherently serial objection too. So there we go. There's my little hobby horse about finals. Oh, here's the one little more bit. This is how I learned that C#5 fixes it. Yeah. Okay, method references. Here is the obscure comment about dot arity. In Java, our method references will have 4 times the dots as C#, so, but it means the same thing. So, yeah, it depends on whether you like dots or whether you're annoyed by them. Like this. Here's an example, which probably any of you could write in your sleep. Here's a functional interface. There's nothing magic about it. It doesn't inherit from delegate or anything. Here's a queryable type. Queryable type has a method called filter on it, which cuts down the population to another collection. And the end user writes something simple, kind of link-like, and everyone's happy. So in order to do this, we need to be able to add types to the collection interfaces, not types, methods to the collection interfaces that weren't there before. And as you know, it's hard to retroactively add methods to interfaces. But luckily, we have concepts like traits. And so we have a variation of that in Java, which is not quite traits, called defender methods. It's sort of more invasive than traits in that the implementation class can override the default implementation. So that gives us sort of cooperation between the interface and the implementation. And also, as you might imagine, we can't introduce fields as a result of defender methods. So what's there to say about it? It's kind of straightforward. It's what you need. The details are so complex that maybe it's not always exactly what you need, and there are gotchas. But this is why language design is engineering and not pure art. So stay tuned on that. Again, Brian Getz has a good blog on it. I'd like to talk, for this group in particular, about translation, the problem of translating lambdas, because it ended up using invoke dynamic in an interesting way. And when you think lambdas invoke dynamic, you immediately sort of put it together and say, well, that means you're using invoke dynamic to invoke the function pointer, but that's not where we use invoke dynamic. We use invoke interface to invoke the function pointer because, as you recall, it's just a plain old interface that you can't tell different from any other interface. So what are the translation issues? Well, first of all, inner classes let you do pretty much everything that you would want to do anyway with lambdas. So lambdas are kind of a syntax sugar first-order approximation for inner classes. So let's translate the lambdas to inner classes. Let's desugar them to inner classes. So here is a reasonable translation scheme, and you can imagine just as inner classes are fairly heavily documented as to what the Java C compiler has to put out when it sees an inner class, there's a fairly restrictive set of rules that say what you have to put in the class file for an inner class. Maybe we could just reuse those same rules for lambdas, and then we're done. So you get something like this. You get, in effect, a little class, a small class file. You know, those guys are about 300 bytes long, and there are 50,000 of them in a Scala application or a inter-class heavy application. And so the actual capture of a lambda or the creation of a lambda would involve just a constructor call. And in this case, notice I've cleverly put a up-level reference to a constant called age limit, and you're testing whether someone's under an age limit. The problem with that, of course, is your jars just get overrun with all these little tiny class files. It's a real problem. It's been there since 1.1. It would also cause problems with making the lambdas look a little bit too much like objects. We don't want to make promises about their identity. If the compiler can prove that that one lambda can be made instead of one lambda per trip through the loop, then we want the compiler to be able to make one lambda instead of one per trip through the loop. So we don't want to have too much objectness in these lambdas. And of course, we want to be able to tune performance. So what do? Well, we could try and translate directly to method handles and then sort of use the method handle proxy interface to wrap the interface around it. So we could require something not like inner classes, but require something that uses the 292 method handle API to build method handles at each lambda creation site. And that would create one class file, which is good, but it would also create fairly complex lambda creation code and would end up making some pretty brittle commitments to the right way to make lambdas. So instead what we want to do is we want to make the creation of a lambda in the bytecodes be simple and declarative. We're not ready to make either the old inner class or the new method handle API be the canonical way to make a lambda. So what are we going to do? Maybe do one now and the other later, but then we have a binary compatibility problem, right? We don't want to have to recompile all the lambda-bearing code every time we lambda folks get a better idea of how to compile lambdas. That would be bad. And this is where invoke dynamic comes in, because invoke dynamic is basically a programmable machine instruction. It takes a declarative set of symbols and lets you interpret what they mean. As long as it comes out to the same thing as a function call. So invoke dynamic can hide the translation strategy. In the compiled code that creates lambdas, a lambda creation is just one invoke dynamic instruction. And the arguments of the invoke dynamic are the captured lambda values. That's pretty simple. You can think of the invoke dynamic as having a declarative set of symbols attached to it. And those symbols say, here's the recipe for how you make the lambda. Here's its body function. Here's its required target type. Here are the placeholders for the bound values that are going to come in. And then invoke dynamic, like any invoke instruction, has a link time aspect. In other words, magic stuff happens the first time you execute it. It links itself, right? This is like what German was talking about with the type descriptors that are sort of lazily resolved in .NET. It gives you a way to sort of expand the program on the fly without having to create it all up front, right? Is that kind of what you get from it? Yeah, invoke dynamic gives you that on a per call site basis, as opposed to in classic Java, on a per class basis, you can use class loaders to resolve one class at a time. But that's an inconveniently large bundle of information to generate one per closure capture site. So the thing that we have a term for the sort of the standard function that is defined by the system that creates the Lambda factories. It's called the meta factory. And when the first time you execute an invoke dynamic instruction, it goes and calls the meta factory and says, meta factory, here's my Lambda creation site. Here are all the types and the body functions and everything. I want you to make me a factory for those Lambdas that's perfectly suited for that Lambda creation site. It creates it. At link time, it binds it permanently to the Lambda creation site. And at that point, it's just a function call to whatever functionality the meta factory chose to build the Lambda. I will show a brief example because that's kind of that's a little bit abstract. In order to understand this sort of one more time around, there are these three phases, each with their own costs. When you first execute a Lambda creation site, there is the sort of setup cost, the linkage of that site. The very first time you run it, you sort of marshal your resources for building Lambdas at that point. Then there's what we call the capture cost, which is really Lambda construction. You capture a Lambda, well, that's the Lambda captures its values and makes itself and turns itself into an interface. That's the capture. And then finally, the Lambda may be executed 0 or more times, and that's the invocation cost. For inner classes, it's pretty simple to see where those costs come in. There's a little class called $1 for an inner class in classic Java inner classes. When you first touch or refer to that foo $1, it does a class load operation, which is fairly heavyweight. And then the next thing that happens that happens once, and then for n times, where n is the number of Lambdas you're making, you do new on that guy and you pass in an up-level reference. How many of you are familiar with the way inner classes are compiled or similar things and similar? Yeah, that's a very high percentage. Very good. So this is sort of the capsule summary of it. And then, of course, eventually, maybe 1,000 or 100,000 times, these Lambdas get executed using the apply function or whatever. And that's just a garden variety invoke interface. The key thing to optimize, of course, is the last, which is the invoke interface. But the capture has to be reasonably efficient, and most importantly, it has to be inlineable so the compiler can begin to connect the Lambda guts to their usage when it can get all the way inlining everything together. So for invoke dynamic, how do those phase costs work? Well, at link time, we call one meta factory, which is a global thing that knows about the VM and is in cahoots with it. And the meta factory says, oh, here's a local Lambda factory that for just this one place. And then that one place, he executes n times over and over again. And that little factory is just happily making Lambdas forever after. And then finally, those Lambdas, as before, run with invoke interface. Meta factory decides strategically how to spin the Lambda being requested by a given Lambda creation site. And it can use inner classes, just exactly the same code as I showed you before, but it spins them behind the scenes as necessary. The important thing is that the Lambda creation site is just a few bytes long and has only declarative information in it. That's the thing I want to emphasize. Because maybe some of you have an application that's similar to that, where you want to make these call sites that expand to something complex and lazy, but and are characterized by declarative static information. All right. Here's some stuff about Lambda lifting, Java style. If you have a Lambda that is stateless, you're going to probably just compile a static function that looks, a static method looks almost exactly like that stateless guy. In a case like this with meta factories, there's going to be just one Lambda instance that you need, and then you're done, right? The same Lambda creation site can produce the same constant over and over again. And we have a K combinator, and that's what it's for. It's called methodhandles.identity. And so the meta factory binds the call site to that constant value, and the compiler inlines it as a constant. All right, what about if there's an up-level reference? Well, then the static function becomes a wannabe Curry function, right? He has some arguments that are applied first during lambda capture or creation, and then the rest of the arguments are applied on lambda invocation. And the metafactory sees that guy and sees the other associated information. He knows what to do with it. He knows that the arguments coming into the lambda creation site are age lim, and the later arguments will be person. Let's see, I think I already explained this slide. Here's the best example I can do. The invoke dynamic does not have, is that a 10-minute? Good. Invoke dynamic does not have a Java syntax, so I'm going to use sort of a vaguely Scala-ish syntax for invoke dynamic. Here we're creating that fellow that has the captured variable from the previous slide. And so that's lambda $2. And you'll notice that inside the square brackets is a bunch of stuff that is intended to read as static arguments to the invoke dynamic instruction. Those arguments, you can have any number of them, and they're just constant pool constants. So invoke dynamic is really like a sort of a function application ready to go in the constant pool. It's kind of strange. So you call the metafactory, you hand it the declarative information, and then what comes back is a guy that takes the age lim and produces the lambda, which is of a desired type, predicate.class. And then there's also various tricks you can do with the metafactory and things that you're forced to do when the thing is serialized. If the serialization can come at you through interfaces, so we deal with it. I don't want to say more about it because it's painful. The important thing to remember here is that it's your own programmable instruction. Whatever metafactory and whatever static arguments you put in for any given invoke dynamic instruction, that's the semantics of it. That's what gets executed at link time for it, the first execution. So it gives you a wonderful hook for, especially when you need your bytecodes to be clean. In the case of Lambda, they need to be clean in order to be standardizable. You might have a compactness reason to make them clean too. And of course, as with type references, it's lazily evaluated. And so if the Lambda site is never created, you don't even compile the inner class, even if there were one there. Pure implementation. Declarative code and crazy optimized under the cover implementation. There is a question about why it's called invoke dynamic. At least it's a question to me. It bothers my conscience that I picked up this project called Invoke Dynamic and then I put all this static stuff into it. Not everyone would have. But the thing that I'm emphasizing here is that we have user-defined linkage semantics for an invoke dynamic instruction. That's about the 5th time I've said it, but that's what I want you to take away from today's talk. And the bootstrap method is that sort of one-time call embedded in the constant pool. So this is open-ended information, and so it's an instruction that you can use. I want to make it clear also, each individual instruction can have a bootstrap method from a different module. So you can have multiple concerns, multiple phases in the tool chain generating invoke dynamic instructions, and they don't step on each other's toes. For Lambda, the extra symbolic information I showed you was in that square bracket. There was forget that. An interesting use case. The extra symbolic constants on the invoke dynamic were added late in JDK 7 because we realized that there were going to be uses like invoke like Lambda for invoke dynamic. And what we didn't put in JDK 7, but we're going to put in 8 to support Lambda, is the ability to crack a method handle constant and get back its internal name and invocation mode and so forth. So we're going to reflect on those, and that lets a method handle constant be a declarative unit of information statically to the metafactory, so we don't have to crack it out as 36 arguments to the bootstrap method. All right. So what was dynamic about that? Well, it's lazy linking, but that's not too dynamic. So Invoke Dynamic provides one other thing, which is completely unrelated to Lambda, which is mutable call sites, which I alluded to earlier. It's the trick of making an optimistic binding to a call site and then backing off of it later on when it goes wrong. But JRuby is using this in production, and Nashorn is using it, and there's a Smalltalk implementation. There's a bunch of people using that feature of Invoke Dynamic too, and that's truly dynamic. So I would say that Invoke Dynamic has these two sides, which can be used independently, but also synergize with each other. The important thing is, for today's talk mainly, is that it lets you get away from small class file infestations. And I hope it helps Scala someday. I really do. I think it could. All right. Just a few odds and ends. I'm almost out of time. I already said that the bootstrap method can take arbitrary numbers of constant arguments in its static invocation. That was something added late in the 7th cycle, so I didn't say that the last time I was here, which was well before the end of the 7th cycle. Constant pool can hold new constant types for method handles and method types. And the most fun part about it, which I do want to say here, is that method handles are fully competent to emulate Java methods. In particular, they know how to do varargs. If you define arrays.asList and you take a method handle on that, the JVM knows that that was a varargs declared method, and the method handle is variadic, which is very useful, of course. All right, what else? I'm about done describing 8, although there's a whole lot more to say. But I want to say, in the last couple of minutes, I want to say what might come next. And this isn't just me dreaming out loud, but this is the good kind of a room to dream out loud in. Been fiddling with tail calls forever. It's going to be real someday. The problem with tail calls is that the devotees and aficionados of tail calls are too few. They're not politically powerful enough. But I'll do my best to push my small weight for them. There's a prototype out there on DaVinci Machine Project for 64-bit reference and primitive unions, so that you can hide references in the denormalized part or the not a number part of floating point numbers, which is a nice trick and not too hard to do in a managed runtime. It's underutilized. I recently blogged on tuples and value types, and it's really cool that Scala's thinking about that too. And there's some other blog entries too, both current and projected, where I want to deal with beginning to do reification right. Please stay tuned on the Maxine project. That's very cool stuff. I, for one, want to program in Java as a systems programming language. I do too much C++ these days. The Graal project will, I hope, eventually allow at least my grandchildren, well, me, to program the JIT in Java. I don't know why we're not there yet, but we're working on it. I want to announce that the JVM Language Summit will be July 30th of this year, August 1st. There will be a call for papers going out in a few days, and I hope to see many of you here, because this is that's another room like this one, very fun and stimulating to be in. What else? I may be out of content before I'm out of time. Well,
questions.
Yeah, questions. So, I do want to say that we are hiring, which I don't know how to say that as a Sun employee, but we're hiring. So, thank you. Questions? Yes.
So I was wondering if the lambdas from Java are going to be serializable.
Yes, but not always. Heaven forbid that they would always be. But if you inherit from serializable, then that's actually something that you becomes a sort of a cooked into the binary interface, because there's too much inconvenient extra stuff you have to do to weigh all lambdas down with serializability.
Is there a plan to get rid of some of the dumb size limits in the JVM, like number of arguments and method size?
How many people have run into method size limits? Yeah. Yeah, some of us have talked. That definitely, there is a work item to get rid of that, yes. Customers need to complain more shrilly, I think, in order for the bill payers to know about that. Argument count, how many people have run into arity problems with 255 arguments? Almost as many. Okay. I want to know what you're programming. That seems weirder to me, but tell me afterwards. Yes?
John, can you talk about performance of your JavaScript implementation on the JVM, the Nashorn thing?
It's performance of Nashorn. It's too early to say very much about it, other than it's much faster than Rhino, and still at least an indirection or two slower than V8. We actually need to integrate maps better into the VM itself in order to get the V8's level of performance, which I think is a good standard for performance. Yes?
So I wondered, can you use Invoke Dynamic to compile some of the existing Java features? Say, I mean, inner classes being an obvious one, or is object identity going to get in the way of that? So you'd get, the same benefits.
Once we say what the translation rules have to be, it's hard to change. So you're asking whether Invoke Dynamic could be retroactively used for inner classes. Maybe if it emulated everything that the inner classes spec said should happen, then it might be. You still see stuff on backtraces that would be funky. I don't know, maybe it would be worthwhile. It would be a way to sort of push those small classes to the side. Good idea. Yeah, Neil.
So you said, going back to modules, that in order to stop torturing class loaders, you want to be able to load more than one module into a class loader. Mm-hmm. So modules can have module private types. And right now in the JVM, a type identity is defined by the class loader and fully qualified name pair.
That's right.
Is that going to change?
That would be a wrong deduction from what I said. The right deduction would be we're still going to have to break a few eggs to make the omelet. Some class loaders will be harmed.
My question is about variants for function types, and do you have variants for function types? And you also mentioned having like a one method interfaces also interplaying with the function types. And I think if you have variants in function types, you may also need them in declaration of.
Right. So Ben, if I mentioned function types, it was in a highly metaphoric manner. The types that you get right now are whatever you code as single method interfaces. So if they have variants, then there's variants. But it's not really friendly looking function types. The best you can do is function 1, function 2, function 3. And then you don't get primitives. And Neil's been down this road some time before.
Last question. So the pace of change of Java has traditionally been really slow. Are we going to see this anytime in the near future? Like when do we get this? That's
the right answer. Thank you. Java 8. Yeah, so Java 7 took 5 years. Oracle is determined that Java 8 will take less than 5 years. But I'm not the one to give information or make promises about schedule. And besides that, my lawyers made me put up that thing to tell you not to believe anything I said anyway. But it's going to happen. The best place to look for schedule information is on the web, and you'll find plenty of Oracle execs giving their best estimates about what we're going to do, and I don't think they're unrealistic. So this Java 8 stuff is going to be real. At least some of what you saw on those slides, especially the Lambda stuff.
All right. Well, thank you so much. Be kind.
Thank you.